This video is going to cover the bleed air system on the 747-400 freighter. We'll just go through straight from FCOM Volume 2 and then maybe talk a little bit about hot topics and how to think about things a little bit smoother, I guess, or how to remember everything that's on the bleed air system. All right, so straight from FCOM 2, introduction, bleed air can be supplied by the engines, APU, or a ground air source. Bleed air is used for air conditioning, pressurization, wing and engine anti-ice, engine start, leading edge flaps, aft cargo heat, cargo smoke detection, hydraulic reservoir pressurization, potable water tank pressurization, air-driven hydraulic demand pumps 1 and 4, and thrust reversers. So engine bleed air supply. Engine bleed air is supplied from either the intermediate pressure or high pressure engine sections, and we'll pull up the systems diagram for this. All right, so we got engine 4 right here, intermediate bleed air and high pressure bleed air. High pressure air is used during descent and other low power setting operations. To prevent damage to ducting and equipment downstream, pressure regulating valve, RV right here, limits bleed air pressure. The fan air pre-cooler regulates bleed air temperature. With an engine bleed air switch on, which will be up here, we'll just look at engine number 4 and the right side bleed air duct. So with the engine bleed valve on, system logic allows bleed air to open the high pressure bleed valve and the PRV, and allows bleed air to open the respective engine bleed air valve and flow into the bleed air duct. The bleed air valves are pressure actuated and remain closed until engine bleed air pressure causes forward flow. The engine bleed air valve closes. This right here will close for these 6 reasons. When a ground cart is supplying air, bleed air over temperature, bleed air over pressure, if a bleed source loss occurs, if a bleed air duct leak occurs, or when an engine fire switch is pulled. So you pull the number 4 engine switch, this engine bleed valve will close. During engine start, here's the start valve right here. During engine start, the engine bleed air valve opens and allows reverse flow of air from the bleed air duct to open the start valve. The PRV is positively closed to prevent reverse airflow into the engine compressor sections. Anytime the engine start valve is not fully closed, the PRV remains positively closed. After N2 increases past 50%, the start valve closes, which enables the PRV to open. Engine bleed air valve reverse flow prevention is enabled. The engine start valve fails to close. Bleed air is isolated from the engine starter because both the PRV and the engine bleed air valve remain closed. Nacelle anti-ice is not available for that respective engine. If an engine bleed air switch is off, the respective engine bleed air valve, PRV, and high pressure bleed valve are closed. If a bleed air overheat is detected, the PRV and HP bleed valves close. Pushing an engine bleed air switch from off to on resets the engine bleed function or fault detection system. Bleed air is available for nacelle anti-ice operation with the engine bleed air switch on, except when the PRV has failed closed or the PRV has been closed due to a bleed air overheat or the start valve is not closed. So let's go up to, here's nacelle anti-ice. Okay. Bleed air is available for nacelle anti-ice operation with the engine bleed air switch off, except when the PRV has failed close or the PRV has been closed due to bleed air overheat, or the start valve is not closed, or the high pressure bleed valve is failed open. And bleed air is available for thrust reverser operation with the engine bleed air switch either on or off, except when the PRV has failed close or the PRV has been closed due to a bleed air overheat or the start valve is not closed. Okay, so If this PRV fails closed, none of this high pressure air or intermediate bleed pressure air can get up here at all. So that makes sense. All right. Makes sense. APU bleed air supply. APU bleed air is used primarily during ground operation for pack operation engine starting. APU bleed air is available in flight up to 15,000 feet if you take the APU running on takeoff. With the APU bleed air switch on, the APU bleed valve opens. I guess we go here, center duct. APU bleed air comes through the center duct right here. Okay, APU bleed air valve, isolation valve right here. Go. ICAS memo message, APU running is displayed when APU N1 is 95% and higher, 95% and higher. APU bleed air is supplied through the center section of the bleed air duct. The check valve in the APU supply line prevents reverse flow of bleed air from the duct into the APU. Bleed duct overheat protection is provided in the APU bleed air system to detect leaks. If the APU shuts down for an overheat, it cannot be restarted. Okay, a couple other notes here. Bleed air supply on the ground. External connectors are provided to connect a ground source of high pressure air directly to the bleed air duct. That again comes through the center duct right there on the screen. And check valves prevent reverse flow of bleed air from the bleed air duct to the connectors. Bleed air duct system, the left and right isolation valves. These are very important buttons up here in case you have an overheat. Isolation valves right here. Separate the bleed air duct into 3 sections, left, center, and right. The system normally operates with the isolation valves open. The valves are controlled by the left and right isolation valve switches. Duct leak and overheat detection system. The bleed air duct overheat system is provided to detect leaks. If a duct leak is detected, the bleed air duct section affected can be isolated by closing the respective isolation and engine bleed air valves. Okay, cool. So that's straight from FCOM 2 for the bleed air system description. When we're naming off all the items that are on the bleed air system, a lot of them are on the overhead panel. And just starting right here, you got the engine bleed. So what's on the engine? The engine start valve. You head up to here to the wing thermal anti-ice. It says that on the panel. Okay, cool. You have wing anti-ice. What else do you have on the wing? Nacelle anti-ice, leading edge flaps. What else is out there? Engine start, we said that. Out on each engine, you have a hydraulic system. So over here, hydraulic system 1 and 4 are pneumatically operated demand pumps, 1 and 4 right there. That's there. The bleed air system goes to the packs, and the packs provide air conditioning, pressurization. They also provide potable water tank pressurization. And this is an important one. In that center duct in here, center duct is the most important, certainly because of this cargo smoke detection. If you don't have cargo smoke detection, that's a showstopper right there. So that's a big one. What else do we have? Lower lobe cargo air conditioning, trim air. I think that's about it in a different order that I've read it off in the beginning. And then aft cargo heat. There's even a button for that. Here's aft cargo heat. And thrust reversers. Thrust reversers. That can be combined with this section down here. Okay. So yeah, they'll ask what's on the bleed air system. So there you go. Mostly you can path out the panel there and include the hydraulic system and cargo smoke detection. Yeah, using this diagram, you're just gonna have to work out when nacelle anti-ice are and are not available, and thrust reverser as well. So PRV failed closed, it's no pressure air is gonna get up there. But if the engine bleed valve is closed for any reason, this air is still in this section of the duct. So you can get nacelle anti-ice and thrust reverser if this engine bleed valve for some reason fails closed. All right, and then let's see, what else are they going to talk about? That's kind of about it from the bleed air system description section of FCOM 2. Good luck.